Okay, so besides noble gases, which I remember we talked about before, atoms all form compounds. Compound kind of sounds like combination. Just a thought. Atoms do this to receive a full valence shell. That reminds me of the octet rule. And in the process form chemical bonds, links. Yeah, I know bonds like bonding. Like you know, if you bond with your parents, you like get to know them and you get closer to them. So I guess chemical links, they join them together. Okay. There are three main ways, so three types of bonding that atoms bond together. Atoms will form either ionic, covalent, or metallic bonds. So those are the three types of bonds. Metallic bonds. The type of bond formed depends on the electronegativities. I know electronegativity is how well an atom attracts electrons. Okay. And the resulting behavior of the electrons. So the electrons matter too. The interaction of nuclei, I know nuclei are the positive centers, and electrons through the electromagnetic force holds atom together. Okay, so nuclei are positive, electrons are negative, and that's how the electromagnetic force works. Alright, so the strongest type of chemical bond is an ionic bond. Okay, so ionic is strong. I'm seeing the word ion here. Since these bonds are so strong, ionic compounds tend to be very hard to melt. Okay, they take a lot of energy to melt, I guess. And very brittle. Okay, I remember brittle means they break, not bend. Ionic bonds are made from metals and nonmetals. Because of the very large difference in electronegativities, nonmetals will take electrons from the metal and form an anion. I remember anions are negative, whereas the metals give up their electrons and form a cation. I remember cations are positive. The cations and ions are oppositely charged, positive, negative, and will attract each other very strongly. Okay. Ionic bonds form repeating structures of positive and negative ions called crystals. So a crystal then would, or let's see, repeating structure of positive and negative. So positive, negative, positive, negative, positive, negative. I guess you could repeat up and down too. So negative, positive, negative, positive, negative, positive. So positive surrounded by negative. I guess that's called a crystal. Okay, so this is a crystal right here. Covalent bonds occur between nonmetals. Okay, so let's see. Ionic was metal and nonmetal. This is just nonmetals, which will both have relatively high electronegativities. So they really attract. They're really attractive. They're like me. Instead of being transferred, the electrons are shared, so that each atom has a full shell. The nuclei of each atom then attracts the electrons, and this attractive force keeps the atoms together. What? Okay, I'm going to look at the figure. Maybe that'll help. So here's the one for ionic. So it transfers of the electron. That seems important. And then we get a negative anion. Well, that's an anion, right? And then we get a positive ion. That's a cation. That's an ionic bond. They attract each other. Here with the sharing of electrons, this is covalent. Okay, yeah, so I mean, in that shell there's two. And then in that shell there's two. So they're both full shells because that's just the first shell. So this is called a molecule. And then I guess what this is saying is that it's attracting to this nucleus, attracting to this nucleus, and so they're kind of like a tug of war, and they stick together. Alright. So where was I? They attract the electrons. This attractive force keeps the atoms together. These combinations of atoms are called molecules. Although the atoms are bound together, the molecules themselves typically aren't bound very tightly. So the atoms are bound together, but the molecules aren't. So like if there's another molecule, it's not bound with this one very much. which means that covalent compounds are usually easy to melt. So easy, in fact, that many are liquids and gases at room temperature. Okay. What else? So it says, if all the atoms involved, this must be metallic, in a compound are metallic, then they will have a low electronegativity. So they all don't attract electrons. Electrons are left to wander around between the metal atoms, which become cations after the electrons leave. Okay, yeah, losing electrons gives cations, which again are positive. The resulting sea of electron forms a field of negative charge, because electrons are negative, okay, which attracts the cations and holds them in place. Okay, so here the sea of electrons, fixed cations, and then there's attraction between these two things, the sea of electron and the cations. So these cations are all attracted to these electrons, which are supposed to be wandering around. Okay, holds them in place. Metallic bonds are almost always stronger than covalent bonds, but are usually weaker than ionic bonds. So I know this has to do with the melting point. So they have a higher melting point than covalent, but lower than ionic, I guess. Since the metal cations are attracted to the negative field of electrons, shifting the structure does not break the bond, and the metals have a very malleable structure. So malleable, I know that means bendable. Okay, last one. Metals also conduct electricity very well. In order to conduct electricity, charges need to be able to move around. It seems important. In a metal, the electrons are free to move, and electrons have a negative charge. So they can conduct electricity then. Covalent compounds virtually never conduct electricity because the electrons are shared between the nuclei of the atom and cannot leave. Okay. In ionic compounds, electricity is conducted only when the crystal structure is broken by either dissolving or melting. So those are the two ways that you can break it, either dissolving or melting the ionic compounds. Breaking apart the ions, which are charged, right, because you have positive, negative ions, allows them to move around and conduct electricity. Interesting. So we have three types of bonds: ionic, covalent, and metallic. If only we could learn more about these. Oh, just wait. Oh, we will. We will.